Hello grade 10s and welcome to this week's lesson on the midpoint theorem. Now really this is the only real new thing that we're going to do, and even though I say it's new, it's not really new because it's kind of common sense. And that's the thing with a lot of the things that we do in geometry. I said things a lot there, but anyway, is that if you actually think about it as normal thoughts and not as mathematical thoughts, you start realizing that actually this does make a lot of sense. So don't overthink things. Don't try and apply mathematical thinking where you just need to think logically. Now, midpoint obviously means the middle point of something, and theorem refers to something that is a proved truth about a certain occurrence of something. So when we say in the midpoint theorem, we're talking about a proved truth about a midpoint. But we'll get more into the theorem a little later on. First, we're going to take a look at the challenge question. Oh, no. Let's see if we can... No, we don't have the challenge question right now. So we're just going to revise some terminology. And the first one is complementary angles. Now this diagram might be a little misleading because the complementary angles are the angles that add up to 90 degrees. So we're really only interested in that. If this was 60 degrees, what would this amount be? Obviously it would be 30 degrees. And what's your reason? They are complementary angles. Okay, and as I said last week, that's not one that we use very often, but we do use it occasionally. Now, supplementary angles are angles that add up to 180 degrees. They don't necessarily have to be on the same straight line, but we do see them a lot on the straight line. So we refer to that as adjacent, meaning next to, and supplementary angles. And basically they're saying, whatever this is equals to, when we add it to this, we're going to get 180 degrees. So x plus y will equal to 180 degrees. Even if I were to move this like that, still x plus y equals 180 degrees. And if I were to make x very small, x plus y still equals 180 degrees. And y, very, very small, it still equals 180 degrees. Okay, then we have vertically opposite angles. And you'll remember from last week that if angles are vertically opposite to each other, whoopsie, I meant to make that y, x, they are equal to each other. So the reason we give here is vert op and then the sign for angles. Why don't we write out the things in full? Because mathematicians are lazy. And so we always try to abbreviate and find the shortest method to find something. Okay, and of course that means if that is equals, then those two are equal to each other as well. Parallel lines and transversal lines. Now, you'll remember that it's very important that the lines are parallel, because lines that aren't parallel can still have a transversal. But when we do the alternate angle, for example, that and that, they are not the same size. And I wrote it in capital letters because I really want you to remember. It only ever works if the lines are parallel to each other. So in the parallel lines, we have alternate angles. And once again, we write it abbreviated, and that will form the Z shape or the N shape, however you want to describe it. And let's extend the page. No, okay, so then we also have this corresponding angles. And those have the F shape. I'm just going to go this way to give myself more space, and then go down. And lastly, we have the co-interior angles. Now I'm writing it up here because they are slightly different, aren't they? The other two are equal to each other, but co-interior angles are not equal to each other. Can you remember there is a special relationship? They add up to 180 degrees, which means they are supplementary. So that's supplementary. Okay, so we have an alternate angle over there, which means that this is equals to that. We have a corresponding angle over here, which means that this is equals to that. And lastly, we have a co-interior angle. Look, it looks like it's on the inside, which means that this plus that equals 180. Okay, let's go to the next page and see what else we need to revise. And types of triangles. Now, you'll remember last week I got you to draw these, and then we went through them. We have a scalene triangle where all three angles are different sizes, A, B, and C, and all three lines are different sizes. Isosceles triangle has two sides that are the same length and two angles that are the same size. And an equilateral triangle has three sides that are the same length and three angles that are the same size. Now, because angles in a triangle are supplementary, let's write that down. Supplementary angles of a triangle. That means that each of these angles are equal to 60 degrees. An angle is equals to 60 degrees. And you'll remember the calculation we did last week to support that. Then on top of that, all of these triangles can also be classified as acute. And acute means all of the angles are less than 90 degrees. All of them. There isn't a single one that is more than 90 degrees. And the reason I stipulate that is because in the obtuse angle triangle, there is only one angle more than 90 degrees. So more than. I hope you are taking notes as we do this, quickly scribbling things down. And a right angle triangle, of course, has your right angle. It's got a hypotenuse, and we can use Pythagoras to find out the rest. Now, all of that is stuff that you should have learned in previous grades. And then we've got to go to similarity. And you'll remember, and I'm just going to draw it up here. Similarity is when we have two triangles that are increased or decreased in the same proportion. So that means that this angle has the same size as this one has the same size as this one, and this one has the same size as this one. But if this was x as a length, then this might be 3x. And if this is y as a length, then this might be 3y. And if this was z as a length, then this would be 3z. So they've been increased by the same factor. In other words, the same proportion every time. So to prove that we have similar triangles, it's best to prove that the angles, the three angles, are the same. And then you can prove that they are similar. I'm not going to read through all of those notes, but I do want to go through congruency again because we actually use it quite a lot. Geometric figures are congruent if they have the same shape and the same size. This means that the corresponding sides and corresponding angles are equal to each other. There are 4 conditions for showing that two triangles are congruent. Okay, so grade 10s. Remember what we said last week. Conditions is a kind of word that is sometimes used when in mathematics that makes people feel confused. So congruent sometimes makes us conditions. Oh, I'm getting all muddled up. Anyway, so there are 4 different cases for congruency. But those 4 different cases for congruency were developed because mathematicians were lazy. In order to prove that 2 triangles are exactly the same, technically, we need to prove that each one of the angles are equal to one of the angles in the other triangle, and that each one of the sides is equals to one of the other sides in the other triangle. So if you tally that up, that's 6 different things you need to prove. Now, mathematicians don't want to spend their time doing all of that, so they figured out there were 4 different shortcuts they could take. They needed to prove that they were either all had the same size sides, because if they have the same size sides, there's only one way to draw the triangle, which means that all of the angles would automatically be equal. Then it's 2 sides with an included angle. In other words, side, angle, side. Or it could be 2 angles and a side. And the last one is the right angle hypotenuse side. So let's look at the note, and please make sure that you have written this down as well. 3 corresponding sides are equal. So that's shortcut number 1, and that's when we prove that it is side, side, side. Then 2 corresponding sides and the included angles are equal. That is side, angle, side. And lastly, 2 angles and 1 side are equal. That's side, angle, angle. But then our special case is when we have a right angle triangle, we can have the hypotenuses, and one of the other sides are equal. So in other words, because we know that it has a right angle, we don't need to prove that it has a right angle. We just need to prove that one of the sides and the hypotenuse is equal. And you'll remember from last week that we proved one question that was in the shape of a rectangle with a line going through. And we had the common line as the hypotenuse, and then the 2 corners were the right angles, and then we just had to show that the other sides were equal. And it was quick and easy. Now, do you remember how we had to write down those proofs? We needed to make a statement, make various statements, and then give reasons. And I told you it was kind of like asking your parents for a favor. Now, I only got my drivers outside of school, so I don't think any of you are going to ask your parents if you can borrow their car, or the neighbor if you can borrow their car, or anything like that. But let's say you did want to borrow the car. Now, you have to give good reasons, don't you? And you have to make sure that the person's in the right mood. So let's say you will go out and fetch some milk, or fetch your younger brother from school, or something like that, in exchange for using the car. You could even justify getting your own form of transport based on those kinds of criteria, like saying, if I have my own motorbike, because you should be old enough to get a motorbike. If I have my own motorbike, then you won't have to pick me up from school. Why? What's the reason for that? I have my own motorbike. So the statement is, you won't have to pick me up from school, and the reason is, in brackets, I have my own transport. And the next statement could be, I don't know. I'm not going to think this through much further. Anyway, today we're doing the midpoint theorem, and so the next slide starts us off with the thoughts about the midpoint theorem. And it says the line segment joining the midpoint of 2 sides of a triangle is parallel to the 3rd side and equal to half the length of the 3rd side. Okay, so what they're saying is that if this is parallel to that, and this has the same length as that, and this has the same length as that, then this will also be half the size of that line down there. Okay, but before we get too much into the proof and things like that, I do want you to have a bit of a break, have a bit of a think about this, maybe draw it down, but mostly just breathe deeply and get ready to take some notes. We'll see you just now. Hello again, grade 10s, welcome back. We're going to now go through how to prove the midpoint theorem. So you'll remember at the beginning of the last section, before we had the break, I said that a theorem is a truth, a generally accepted truth. And the midpoint theorem talks about the midpoint of something. Now in this case, it's talking about the midpoint of a triangle. And it's saying that if I have a triangle and I've got a line going through the midpoint of two of the sides, that line will then be parallel to the base, and it'll divide those two sides in half, which I suppose makes sense because they are joined from midpoint to midpoint. Okay, now we are going to prove this. It is much easier to start off by cutting out a triangle in a piece of paper and then folding it in half and cutting it and seeing if they are parallel, the lines have the same parallel features, and also seeing how the lengths of the sides compare to each other. It's just a really nice exercise, but obviously I'm a little limited today, so I'm just going to show you how to prove it mathematically. Okay, I don't want you to get all worked up about this theorem. I want you to see how we can use it rather than how to prove it. So the proof is just important to show you that it's true, but you need to know how to use it more than anything else. Okay, so to prove this, I'm going to make a construction, and a construction is a drawing that I'm going to add myself. I'm going to, let's not start with that line. Let's just get rid of it quickly. I'll drag it to over here. The reason I don't want to start with that line is because I actually want to extend, let's do it with dashes, I want to extend this line so that it's the same length as the other one, and I'm just going to check that it is the same length. Nope, so I will make it shorter and then drag it over. Okay, so I've made it exactly the same length as that other one. Now let's pull over this line, which is meant to join the corner of the triangle to the corner of the new triangle that we've created. Okay, I'm going to label this triangle quickly and label it A at the top, then B down here, and C over here. Then let's label this line DE, and because I've extended it, I'm going to make that F. So I have constructed that extra triangle. Okay, now I need to prove that these two things are parallel. So I'm going to start by working with two triangles. I'm going to start with triangle ADE and triangle EFC. And the reason I'm going to do that is because I have been told that that is equals to that and that is equals to that. Okay, so I had already been told that, but I need to prove that this triangle over here is congruent to that triangle over there. Because if I can prove that they are congruent, then I might be able to find out what that value is and that value is. And if those two values are the same, then it would prove that this line is parallel to that line, which would mean that I would have a parallelogram. Okay, but that's a lot to get into now, so I'm erasing all of those other lines, and let's start with proving congruency. So we always need 3 facts to prove something. If we look at the triangle, we can see that this angle is equals to that angle over there. Why? Because they're vertically opposite. Then we also know that this side has the same length as that side over there. And we've been told that AC or AE has the same length as EC. So there are our first three things. We've got a side, an included angle, and another side. So let's start by saying, and we'll switch back, that AE is equals to EC. Why? Because it was given. Okay, the second thing we need to prove is the angle. Well, angle AED is equals to angle CEF. Why are they equal? Because they are vertically opposite. Okay, and the last thing we need to prove is that the other two sides are equal, and they're equal because we constructed them to be equal. So DE is equals to EF. Why? Because we did it by construction. Okay, so I'm going to abbreviate construction, and there we go. And so therefore, triangle ADE is congruent to triangle, and we have to be careful now, A has the same size as C, so that means it's going to be C, then F, then E, so that they are listed with their corresponding sides. Okay, the reason why that is important is because we need to determine whether that over there has the same size as that over there. And would it have the same size? Well, they are corresponding angles, which means they are exactly the same. Exactly the same. I think I said corresponding and I meant to say congruent. But congruent triangles are exactly the same in every way. So that means, and I'm going to keep it blue because now I'm just going with a different sort, that angle ADE is equals to angle EFC. Why? Because triangle A, and I'm going to run out of space, ADE is congruent to triangle CFE. Oh, I made it by the skin of my teeth. And that means, because this has formed a Z shape, and because this angle is equals to that angle, they are parallel lines. Because this kind of relationship only ever happens when the lines are parallel. So that means that AD is parallel to FC, and the reason is alternate angles are equal. Okay, now because those alternate angles are equal, we can then surmise that this is a parallelogram. And how do we do that? Well, we've got two parallel sides. Do we know that this is the same length as this side? Well, I'm not sure if we do yet, but we can prove it, can't we? We know that, and let's go up a little bit, we know that AD is equals to BD because that was given. And we also know that AD is equals to FC because triangle ADE is congruent to triangle CFE, and obviously you would write that out in full. Therefore, BD is equals to FC. And therefore, BDFC is a palm. Palm is the abbreviation for a parallelogram. Okay, so if that's equals to, if DB has the same length as FC, it means that DF has the same length as BC. And we know that the midpoint of DF is E. Why do we know that? Because I drew it. So I knew from construction. So if I have divided it in half by E, we know that BC will equal 2 times the length of DE. Okay, Gr10. I know your minds are now spinning quite a lot because I've actually thrown something at you that is quite abstract. I don't want you to focus on the theorem. You may be asked to prove a theorem in an exam, but more than likely, you're going to be asked to use the theorem a lot more than prove the theorem, which means that it's more important that you feel happy with using it rather than proving it. And using it just requires us to remember that if there's a line drawn from one side of a triangle to the other, and it divides both of those sides in half, that line will automatically be parallel to the line at the bottom, and it will automatically be half the size of the base. So that's all I need you to remember. And then you would say as your reason, in brackets, midpoint theorem. And your teacher would go, oh, you're amazing, and tick your work just like that. Okay, so don't get too wrapped up in the theorem right now. Remember that you need to go through it later after you've used this theorem a few times. But for now, I want to get to some questions. So let's look at the questions. And here is the challenge question. PQR is an isosceles triangle with PR equals QR. S is the midpoint of Q, T is the midpoint of PR, and U is the midpoint of RQ. Prove that triangle STU is isosceles. Okay, I'm going to give you a minute to write this down so that we can go through it again next week. Okay, now that you've written that down, make sure that you keep it safe. Maybe you try it by yourself. In fact, I think you should try it. And you should write down your answer. Get your teacher or your friends or someone to go through it with you and check that you've written down the reasons like you would want them to be in a test or an exam. Why? Because your mark is your responsibility. So you need to make sure that you're getting the best you can get. Okay, with that pep talk, it's now time to look at a question that we can do together. And this one has a picture of a triangle with a triangle on the inside. And it says triangle ABCD is a right-angled triangle at A. D is the midpoint of AB. DE is parallel to BC. and FD is perpendicular to AB. So I'm going to draw this in, and I'll start with D is the midpoint of AB, and that means that this side is equals to that side. Then DE is parallel to BC. Now that of course tells me, according to the midpoint theorem, I could probably conclude that those two sides are equal. But it wasn't given to me, so I'm not going to do anything about it now. I'm just going to ignore it. Then, FD is perpendicular to AB. Well, here is FD perpendicular. Oh, and I forgot to do the right angle at A. So I've got that going on over there. Well, that's quite interesting, because corresponding angles are only ever perpendicular if the two lines are parallel. But we're not required to know that just yet. So for the next minute, I want you to attempt these questions, and then we'll go through them. Okay, grade 10s, you are now going to have a bit of a breather and a break to go through things. I know you haven't finished doing these questions yet, but now's your chance to discuss them with people next to you. Remember that geometry is not meant to be difficult. So if you're finding the answer easily, it's because you're doing it right. Okay, we'll see you after you've had a bit of a stretch. Enjoy it. Okay, grade 10s, welcome back. Now we're going to go through those questions. Remember, they're meant to make you feel clever. They're meant to make you go, is this all? Is this really all I have to do for these marks? So if you're feeling that right now, then you're on the right track. But if you're still feeling overwhelmed by the proof of the theorem, then you need to let go and just feel more free and easy in this. It's meant to be enjoyable. Okay, so let's go to the questions. The first question asked us to prove AE was equals to EC. So I'm going to open up a new slide where I have just that question written down. And we knew that that was equals to that, and we were told that that line was parallel to that, and we were told we had a right angle there and there. That was our given information. And we are required to prove. So RTP means required to prove that AE is equals to EC. Now, that's actually really nice to write at the top of a question when you give your answer, because then it reminds you what you need to do. And AE talks about this line over here, and EC talks about this line over here. How do we prove that those two are equal, other than by just saying they're equal? They are equal, aren't they? Why? Because of the midpoint theorem. But we only know that the midpoint theorem is going to work over here because that side is equals to that side, and because that line is parallel to that. So before we can say that AE equals EC because of midpoint theorem, we need to first state the obvious. So this is the end result. Is it where we get our marks? Not all of them. We need to first state what supports this midpoint theorem theory. And that is, firstly, that AD equals DB. How do we know they are equal? It was given to us. In other words, we were told about it. Then we were also told that DE is parallel to BC. And this was also given. So that means, according to the midpoint theorem, AE is definitely equal to EC because of the midpoint theorem. And that's the whole proof. That's all you have to do, nothing else. How do you feel? You feeling good? Feels a bit strange, doesn't it? Like you just have to tell them what's obviously there. It's kind of like talking to a child and you're talking about going out and you're saying, okay, well, we're going to leave now. But before we leave, it's obvious that you need to put on your shoes. And before we leave, it's obvious that I need to pick up the car keys. But then we can leave. So the outcome's still the same. We're still getting there. But we need to state the obvious first. Okay, it's the one time you'll be allowed to treat your teacher as if he or she is stupid. You're really explaining the basics to them. Let's go on to the next part of the question. And the next part says, we've got the same diagram. We need to prove that DF is parallel to AC. So we have our given information, which I'll just draw in quickly. And then we have what we proved just now, where that is equals to that. Now we need to show that DF, that line, is parallel to AC, that line. Oh, and we did speak about this in the beginning. I'm going to start by saying required to prove. And I'm required to prove that DF is parallel to AC. Let's make that a C. Now, how am I going to prove that? I can see that they are parallel, but I need to state the obvious. And the obvious is I have two angles that are equal. And those angles are forming a lovely F shape, like that. Remember how I colored it in last week? Like that and like that. And what do we call that? And here's my little trick for remembering this. Those are corresponding angles. And you see, I remember it because if you put the R's on top of each other, it kind of looks like an F. So corresponding angles, whoopsie, are equal. Corresponding angles. That's our thing. But first we need to state that D equals A. And then we can go on with the rest of it. So that's step one. Angle D is equals to angle A, and they're both equal to 90 degrees. How do I know this? Because it was given to me. I was told right in the beginning. Here, right angled at A, and FD is perpendicular to AB. Okay, so that means that the two lines are parallel. I don't have to prove anything else. I just have to say, therefore, DF is parallel to AC. Why? Because our corresponding angles are equal. Corresponding angles are equal. And that automatically means that the lines are parallel, because corresponding angles can only be equal if the lines are parallel. Okay, now there's one last part to this question, so let's go to that. First, let's draw in the information that we know already. That side's equals to that. That is parallel to that. Then we've also proved that this side is equals to that side, and we've proved that this line over here is parallel to that line over there. We know that this is the midpoint, so what do you think f is to the line BC? Thinking, aren't you? I hope so. Prove with giving reasons that BF is equals to FC. Well, that's going to be quite easy to prove. Why? Because we know that this side is equals to that side, and this line over here is parallel to this line over here, and therefore the midpoint theorem states that F is the midpoint. So let's write down required to prove BF is equals to FC. And I know I'm going to prove it using the midpoint theorem, so I'm just going to write down over here as my conclusion, therefore BF equals FC and midpoint theorem. Okay, I suppose I should write theorem. There we go, theorem. Okay, but I can't just state that. I need to say why the midpoint theorem applies. So I say that AD is equals to DB. How do I know this? Because it was given right in the beginning. We were told this. Then I've just recently proved that DE is parallel, DF. DF is parallel to, let's see what that top, AC. And for that reason, I can say proved, because I proved it above. So that means, therefore, BF equals FC because of the midpoint theorem. Okay, grade 10s, do you see how easy these questions can be? So you just need to look at things and then figure out how to state them, because it really is obvious that F would be the midpoint of that line. But figuring out how to argue that it's the midpoint of that line is what's so important. So it's all about making those statements and having the reasons, because that will back up the last thing that you need to say. Personally, I find it easier to write what I need to prove and the reason for the proof at the bottom, and then figure out the steps in between. Also, before I even write anything, I need to have a clear direction of the path I'm going to take. Okay, let's go to the next question. Okay, it is given that AC is parallel to MK. So let's put that in. AC is parallel to MK in triangle LMK. And LA has the same length as AM. So I've drawn in the given information. Prove giving reasons that B is the midpoint of LN, that LC is equals to, so B is the midpoint of LN, LC is equals to CK, and BC is equals to half NK. Okay, grade 10s, I'm going to give you 2 minutes to attempt these by yourself, and then we'll do the answers together. Okay, grade 10s, we don't have a lot of time left, so I'm going to go through these solutions quite quickly. Okay, but that's okay because this is easy, isn't it? It's just stating the obvious. Okay, so the first question asked us to find, well, that B is the midpoint of Ln. And I'm just going to put all the information back in. We said that AC was parallel to MK and that LA was the same size as AM. So obviously that means we're going to be using the midpoint theorem. Why? Well, we've been told that those two sides are equal in length. And we've also been told that those two lines are parallel. So our truth tells us that if that is so, then this over here should have the same length as that. Not should have, it will have the same length as that. But how do we state that? I'm going to start by saying my conclusion. Therefore, B is the midpoint of Ln. And the reason I'm going to do this is because it helps me to work backwards. And if B is the midpoint of Ln, what I'm actually proving is that LB is equals to Bn. So that's going to be what I say before this. LB is equals to Bn. And why are they equal to each other? Because of the midpoint theorem. Can I just state this out of the blue though? No, remember that I needed to prove this whole thing. So there's still steps in between that I'm missing out. How am I going to prove that the midpoint theorem applies to this particular problem at this particular point? And that is by stating the obvious. And I know I've got all sorts of lines and colors going here, but bear with me. Okay, so we're going to state the obvious and say that Lm or LA, oh, I wanted to change to blue. LA is equals to AM, and how did we get that? Well, we didn't. We were told it. And we were also told that AC is parallel to MK, and because we were told it, we say it was given. So that means the midpoint theorem does apply, which means that B is the midpoint of Ln. Not bad at all. Okay, so we know that those two sides are equal, and those two lines are parallel, and these two sides are equal to each other. Let's see what we need to do now. We need to prove that LC is equals to CK. So now we're looking at this line and this line over here. It feels pointless, doesn't it? Because we are just proving the same thing over and over again. We're required to prove that LC is equals to CK, and why are they equal to each other? Well, you and I both know that they are equal to each other because of the midpoint theorem. But we need to explain how we came to that conclusion. We can't just say that it's the midpoint theorem, get lost in my spelling. We need to give evidence that backs it up. So we need to fill up that space over there. And we're going to fill that up by once again stating the obvious. We have a triangle. Maybe we should state that we have in triangle LMK, LA is equals to AM. Why are they equal? Well, it was given. And AC is parallel to MK. How do we know this? Once again, it was given. So basically, we've answered a different question with the same reasons as we had before. Okay, and I know we have run out of time, so the last thing I would say is that we know because this is the midpoint theorem, and that's the midpoint of this triangle over here, they are automatically, this relationship automatically exists because of the midpoint theorem. Okay, grade 10s, it's been great fun. And I know that you are going to be fine in this. Remember, just state the obvious. It feels like you're talking to a child, but that's okay. Have fun, and I'll see you again next week. Goodbye.